Okay, so welcome everybody and good morning. I think this is a very special occasion. I have the simple job, which is simply to welcome you and to introduce our main speakers, who will have the much more complicated task of explaining why we think this is a special moment. And we do think it's a special moment because there is, at the moment, a fierce debate about evolutionary theory. And we think that we are in the middle of a fairly significant and radical change. So that the theories that were so brilliantly evoked by Charles Darwin and then his various successors, loosely termed neo-Darwinians, is now under challenge again. And I hope that our guests this morning will be able to explain a little bit about how this works and how exciting this is for our future thinking, about how our bodies work, and maybe how thinking and machines and future inventions may be constructed. As I say, this is in a sense complicated, but complicated in an interesting way. And we can only marvel at how, as we understand more and more about ourselves, how amazingly they have this power to engineer change in a way that's way beyond our current capacities for understanding. And even though people tend to marvel so much about artificial intelligence, we're pretty convinced, aren't we, that cells are far and away ahead of the game. And the really exciting thing, and I think this is what we're going to be discussing this morning, is to see how we can further our knowledge of the way the cells can change and the direction. It's not a simple linear direction, it's much more randomized, but nevertheless it's randomized with a purpose. So I do think this is an exciting moment, and thank you all for joining us this morning. So my job now is to introduce our first speaker, Professor Denis Noble, who's a scientist extraordinaire. We regard him very much as our dear friendly polymath. He's a physiologist, he's a biologist, he's a philosopher, he's a linguist. He's also an activist, and I personally got to know him best when he started a campaign to save investment and research in science, the famous Save British Science campaign in the 1980s. He first came to prominence with his work inventing a model of the human heart, which eventually led to the introduction and development of pacemakers, which we're all familiar with. So he's very much involved in these current debates around the idea of systems biology, and he's expressed his ideas in two wonderful books, very easily readable, very accessible: The Music of Life, and more recently, Dance to the Tune of Life. Denis, would you like to explain a little bit more about the current debates and what's happening now, the background to this prize which we're going to be announcing shortly?
Yes, thank you, Paul, for that. I'll be fairly brief. It seems to me that, yes, there is a lot of discussion now about the fundamentals of biology. I was involved just 3 years ago in helping to organise one of the rare joint meetings between the Royal Society and the British Academy, which occurred 3 years ago in 2016, has been published in the Royal Society's journal Interface Focus. And the articles in that issue, which are under the heading of New Trends in Evolutionary Biology, Biological, Philosophical and Social Science Perspectives, indicate what is going on. It was an absolutely fascinating meeting, and incidentally the huge hall here was completely full. In fact, there was a huge waiting list for people to come to the meeting. One of the people who was present was Perry Marshall, and I'll come on to Perry in just a moment and to the prize. The next significant development for me was meeting up with a remarkable bacteriologist at Chicago University, James Shapiro, who wrote this book, Evolution: A View from the 21st Century. James Shapiro worked for a period in the last century with Barbara McClintock, and some of you will know that her major discovery was of what we sometimes call jumping genes, the ability, as she found in chromosomes in corn, for chunks of the genome to move from one part of the genome to another. Well, of course, she wouldn't have called it the genome in those days. It wasn't even known that it was DNA that was the basis of the genetic material. And she received the Nobel Prize for her discovery of what we would now call mobile genetic elements in, I think it was 1983, at the age of about 81. Jim's book explains how that led in turn to him questioning some of the fundamentals of the way in which DNA is interpreted. Nobody, incidentally, and certainly not in this room, is challenging the importance of DNA, the importance of there being a database there that enables cells to pass on from one generation to another the valuable information that is in DNA. I think what is common between certainly some of us is that it's that DNA is more controlled than it is controlling. That's the way I would put it, and that's exactly what Barbara McClintock thought too. In her Nobel Prize lecture, which was published in Science, she said the genome is an organ of the cell, which I think gets the idea of causation the right way round. And that leads me to Perry. Now, Perry, you're extraordinary. You are a businessman. You have a reputation for marketing. You have bestsellers in books like 80/20 Sales and Marketing, Ultimate Guide to Google AdWords, and Industrial Ethernet. But you end up also publishing a book which has a title not very different from James Shapiro's, Evolution 2.0, whereas he has it as a view from the 21st century. I read this book very, very carefully because I found it initially a bit puzzling how somebody like you, with your background, admittedly with technological knowledge, starting off as an engineer, yes, right? But still, I was intrigued to know to what extent were you getting any of it right? And he does, more or less, because what he writes is not very different in terms of perspective from what I write in my own books. And so when Perry approached me with the news that he had a number of investors willing to put up a major prize, I was intrigued. Now, why should there be one? As I see it, okay, we're adding various processes to the story of evolutionary biology, particularly the control by epigenetic factors and the fact that material can go down via microsomes to the germ line and so on. But it leaves two things, it seems to me, then completely unexplained. How did life get going in the first place? And what is the origin of the genetic code? And I would regard those as the two very, very big questions for science today. On how life got going in the first place, there are people trying very hard. Lee Cronin is a good example in Glasgow, to start with simple chemistry in a dish to find out how it could be that proteins might have evolved from simple structures to very much more complicated structures. But we're still a long, long way away from understanding how all of that could come together in a cell and then eventually develop a store, which is DNA. I put it that way because I can't see personally how DNA can have been there at the beginning. After all, it requires the cell to enable it to reproduce. It requires the cell also, incidentally, to correct errors in that reproduction replication process. But that then leads to the other big question then, as DNA evolved, where did the specific code, these 3 nucleotides mean, if that's the right word, this particular amino acid, where does that come from? Because with triplet code, there could be many possible ways in which you could arrange that. So did it happen by the chance chemistry being that it went one way rather than another, in which case there's no explanation at all? Or is there some good chemical reason why that code should be as it is rather than anything else? And that would be important to questions like, if we find life on Mars or one of the moons of Jupiter or wherever we might eventually find it in the solar system, will we find the code is the same? Will we find the code at all? Or could it be that you've got organisms that are essentially cells without DNA? Not impossible, incidentally. So I agree with you, Perry, that it's the biggest challenge that at the moment we could say that biology faces. I say the biggest because you might think the origin of life is even bigger. In a sense it is. But I think this just conceivably could yield to the way in which the chemistry process enabled it to happen in the first place. I just somehow think there has to be a reason why it is as it is. So when you asked me whether I'd be on the judging panel for this, I tell you my first reaction was that I don't know enough. And I think it was probably...
That's what you said.
That's what I said, exactly. And I'm not sure whether George Church at Harvard said the same. I hope not.
No, he didn't actually say that.
No, good. And Michael Ruse, is it, at...
FSU?
Yes, at it's Florida State, yes, who is a philosopher. And incidentally, just to reassure those who might wonder whether there are any sort of somewhat metaphysical questions being involved here, he's a card-carrying atheist come agnostic. So at least we get that one on the table. We are a funny old mix.
Yes.
Anyway, I think the best thing now, Perry, is you tell us why you decided to launch the prize. Why is it as big as it is, and where does all the funding come from? Here you are, there are the questions. Over to you.
Okay, well...
And I'm sure you'll get even more difficult questions from around the table.
Well, good morning. Thank you. It's an honor to be here at the Royal Society. Well, so we're here doubling the prize amount, and it's the first significant activity I've had here in Europe discussing this. And so I'm just going to tell you probably about the first 10 minutes here. I'm just going to give you the background, and then we'll do Q&A. After that, I'll have a little word from Kevin Ham here. So this story starts literally in this little Chinese bus in Western China, where I went to visit my brother in 2004. And my brother was an English teacher who was also working part-time as a missionary in China. And we had been having these discussions back and forth because he was increasingly doubting the whole religious thing writ large. And so these emails were going back and forth, and we were discussing. And when I got there, I realized he's thrown this whole thing out the window. And we're pastors' kids. So this is a bit of a shock to my system. A little bit of shock to the family dynamic, shall we say. And so I was feeling a little uncomfortable, and we got into this argument, and I would say that I retreated to my comfort zone, which is engineering, because I said, Brian, look at the hand at the end of your arm. I said, this is a nice piece of engineering. I said, you don't think this is a collection of random accidents, do you? And he goes, hold on. And he just came right back at me with a standard, Perry, all you need is random copying errors of DNA and natural selection and millions of years, and you'll get a hand, and you don't need any engineering. And now, I didn't really have a problem with evolution per se, but I'd never quite heard it phrased that way. I'd always looked at my hand and said, there's something very, very intentional going on here. And he was challenging that. And I just, in a few seconds inside my own head, I thought, okay, I already know without pushing this argument any further that there's a whole bunch of biologists that would agree with him and not agree with me. And I know from what I've done so far in my career and in school that there's a lot of things in science that are very counterintuitive. And you know what? I don't know. So like, Perry, why don't you stop arguing with your brother right now? And it wasn't helping anyway, if you know what I mean. You know, we're trying to have this pleasant visit, and it's, you know, okay. And I made a decision. When I get home, I am going to get to the bottom of this. He had already been dragging me with him against my will anyway. And I already had this whole cloud of religious and philosophical questions. And I said, you know what? I'm an engineer. I know how to read a scientific paper. I'm scientifically literate. I'm going to go home and I'm going to let science make this decision for me. And you know, my belief system could completely change, and that's terrifying, but you know what? Here we go. And I just leaped into the void. And that's how this started. Well, so what's about to follow is a story of transforming what started as a philosophical and religious question and turning it into an engineering question. And then eventually turning it into a prize. Okay? And so I went home and I started obsessively reading and buying books. And I'm an entrepreneur, and if you know entrepreneurs, they're all obsessive, compulsive kind of people, and they just, probably scientists are too, I imagine. But I just started buying books and going to websites and voraciously digesting things from all parts of the spectrum, everything I get my hands on. So here's what I discovered. I wrote, well, for a while, I floundered helplessly. I was just inundated with information. And I couldn't make sense of it, and I couldn't figure out, like, what's the starting point with this? And which facts do you put first and which facts do you put second? Well, one day, I was trying to understand DNA, genetic mutations, the genetic code, and I suddenly had this flash of recognition. And here's what it was. I had written this book, Industrial Ethernet, which for a major society of process control engineers. And if any of you have trouble sleeping tonight, this may help. But it actually turned out to be kind of fascinating how all the ones and zeros go on a wire and how ingenious all of it is. And I was studying DNA and mutations and all of that, and I was like, wait a minute, I've seen all of this before. I know what this is. Now, the diagram on the screen shows the dissection of an Ethernet packet on the top, and on the bottom, transcription and translation of DNA. And you can see just graphically how similar they are. Mathematically, they're identical. It's encoding and decoding. It is a communication system. There's an encoder, a message, and a decoder. And all of a sudden, I had all of these familiar things that I could attach all of this to. I'm like, okay, I can start with this. I understand genetics. Genetics is digital communication. I understand digital communication because I wrote an Ethernet book. Suddenly, in a whole bunch of things, like a whole bunch of suspicions, also came along, which it took 2 or 3 years to later confirm, but it all just fell into place. The ABCs of a communication system is that you have an input that goes into an encoder, it gets turned into a message, and then it gets decoded. So I send you a text message, it gets encoded on my phone, it gets turned into ones and zeros, and it comes into your phone through Wi-Fi or what have you, and you read the message, and if what was put in corresponds properly to what came out, then communication has successfully happened. On the left here is part of an ASCII table. 100001 is a capital A, and 100010 is a capital B. And in DNA, AAA is lysine, and GGG is glycine. And so if you have an encoder, message, and a decoder in a table, you have a communication system. And that's exactly what, it's in every biology book known to man. As I started to explore this, I came to this realization that there's 1 million codes, 999,999 of them are designed, and then there's one we don't know where it came from, and it's DNA. Now, what I told Denis when we talked on the phone after the Royal Society meeting 2.5 years ago, I said to Denis, 10 years ago, when I was sort of in the beginning of this, you could have pegged me as a card-carrying intelligent design guy based on exactly what I just told you. It's like, well, to an engineer, this looks totally designed. But there were a couple of things that caused me to shift my position to be very much in concert with what Denis and people like James Shapiro and others espouse. Was maybe we'll get into this later, it's kind of up to you. I got very fascinated with evolution itself. And when I discovered Barbara McClintock, my inner geek just went crazy, because she discovered that corn plants cut, splice, edit, and re-engineer their own DNA in real time. And to an engineer who was tempted to be a creationist, I suddenly saw it was like a whole universe opened up. I'm like, oh, this is way, way more interesting than anything I've been told so far. Now, this was in probably 2006 that I discovered Barbara McClintock, but it took me 2 years of reading and researching before I actually found this. I'm like, why isn't this front page news? And so I became immensely fascinated with evolution itself. This is the greatest engineering problem ever. And neither of the camps, so to speak, are doing it justice. Well, and then you get to the origin of life and the origin of code, and it would be easy to just abdicate to a divine explanation, but I suspect that there are some principles here that science has not figured out. I still believe in God, but I don't like God of the gaps arguments. I think they routinely fail. And we're trying to get past this. And so here's how the prize works. If you can produce a self-organizing digital communication system, we'll write you a check for $100,000, and there are no other strings attached. The first person that shows up who's done this, they get a check. But if your process is patentable, then Natural Code LLC will fund the patent and pay you $10 million for the rights for it and partner you into the company so that you participate in the profits as it grows, because I think this would be extremely valuable intellectual property. I think that origin of life, evolution itself, AI, and maybe consciousness are really the same single problem, not 4 problems. And I think in answer to this question of how do you get from chemicals to code would unlock the door to all of those problems. That's what I suspect. I don't know that that's true, but that's what I suspect. Okay, why a prize? One, information is the central question in biology. Where does the information come from? How is the information processed? How is information from one species to the next in an evolutionary process? How is that information actually generated? Number two, computer programs don't write themselves, but cells do. DOS did not evolve into Windows by itself, but bugs evolve into superbugs in 30 minutes. So there's something that people in the software world don't understand at all. Number three, Alexa and Siri understand every word you say and they have no idea what you mean. Your dog doesn't understand a single word you say, but your dog knows what you mean. There's a fundamental difference between biology and human technology, and I think this would bridge that gap. Number four, a solution to this will revolutionize technology and medicine for reasons that should be obvious, but I think we can talk about in the Q&A. And fifth, and this is one of the reasons I wanted to have this meeting. Last summer I had a long conversation with George Church. He's godfather of modern genetics, you could say. And we talked about the risks and the dangers of gene editing and CRISPR. We can edit DNA as easily as inserting a picture into a blog post. And you can buy a gene editing kit on Amazon for $169 US with free shipping, okay? And I think that this information question has not been treated seriously enough. There's not enough journals about it. There's not enough books about it. Most people are dealing with this as a chemistry problem. I think it's an information problem. And if we don't take this information problem seriously enough, I think we're going to make some very big mistakes and we won't be able to put the toothpaste back in the tube. And I hope that we can talk about that today. So, judges, George Church from Harvard and MIT. Everybody in genetics knows who he is. Incredibly prolific, 43 patent apps, fascinating guy. Next judge, Denis Noble from Oxford, first to come on board, needs no introduction here. Michael Ruse from Florida State University, the president of HeroX, who hosts our prize, said, Perry, you're a Christian and people are automatically going to think this is like some kind of, I don't know, intelligent design publicity stunt. Can you get an atheist on your panel? Let me see what I can do. Yeah, so we got Michael Ruse. I love Michael. He's a hilarious guy. He's also very friendly. He's not combative. He's been involved in many debates and discussions about science and religion. He's been in some of the creation trials as an expert witness in the United States. You all know how different the United States landscape is with this question than Europe. So he came on board. So I have these judges. And at naturalcode.org, we have the whole prize description. It redirects to the HeroX website. We have a $10 million prize, and I think we need a substantial sum of money to pinpoint the importance of this question. So.
Okay, thank you very much, Perry. So just to reiterate, what we're announcing today is that the prize is now $10 million, and that's completely new and a huge increase from previous thinking about it. It's the first time, Perry, that you've talked about this prize beyond America. Yeah. So this is, in a sense, trying to turn the prize into a global prize. Mm-hmm. And the third key element is that you've realized that this prize is beyond chemistry and biology and engineering. It's really about information, which is central to the way that we operate in society and in terms of our body. So these are the major announcements this morning in the Royal Society in this very special conference room?
I think this is the most fundamental question in science that can be precisely defined.
Well, thank you very much. Now, we're going to open it up to questions, but before I do, we're going to bring in a close colleague of yours, Kevin Ham, who's kindly joined us, flown in this morning, who wants to add his perspective on this.
My name is Kevin Ham. I'm from Vancouver, Canada, and I flew in for this occasion and the announcement of the 10 million X Prize. I'm one of the investors, and I just wanted to give you a background story of how I came into it, which leads me to my childhood. When I was 14, I was skating around on an ice rink. By supper time, I could barely bring my spoon to my mouth. By dinner time, I could barely walk. I ended up in a children's hospital, admitted for autoimmune disease. While I lay in bed for the next few weeks, I wondered if I was going to live. And if I did, I decided I was going to be a doctor. So that was kind of like my mission in life. At 16, I started studying, reading the Bible. I came to believe there was a God. I did a Bachelor of Science in Biochemistry, and then I got into med school, finished med school, became a family doctor at age 30. While I was in my medical residency, I saw 40 patients a day, 10 minutes per patient, and I just thought it was like a factory. And so I thought, you know what, I don't want to do this like a business, so I knew that the internet was going to be a revolutionary medium, greater than any media revolution that we've experienced in history. So I decided to create an internet business. So I did that. It started making more money in 1 month than I did the whole year in residency. And so I thought I'd do that for about 6 more months and then go back to medicine. But I haven't gone back to medicine. I'm still doing business. I met Perry in 2016, about 3 years ago, and we were having dinner, and I went to meet him because of his 80-20 book. And his book talked about 80-20 being fractal. And so there's an 80-20 inside of 80-20, and that fascinated me, and it totally changed the way I thought about business, about life, about everything actually. So we were having dinner, and then he started telling me about this book that he had written, Evolution 2.0, and that fascinated me. After our 5-hour dinner, I put my hand out and I said, I'm in. I want to be involved in this prize. And he told me he was trying to get investors at $1 million in. So I said I'm in. I was the 5th investor. And then we started having these annual meetings. We had our first one in Hawaii, our second one in Napa Valley, and our third one is going to be in Iceland this summer. And so now the number of investors are double at 10. And so it creates this very eclectic, unique group of people from all walks of life. And so that's pretty exciting. Part of the thing that I got from this was, that makes a lot of sense, what Perry just described. That, yeah, this genetic code, you know, all of us with 23 pairs of chromosomes multiplies, and then it differentiates into all these diversified cells that become tissues and organs and, you know, billions of unique beings and species. And all, even with the same code, you get different expressions of beings, even with twins and triplets and so forth, based on the external factors, internal factors, and that's just so amazing. And then I thought, why isn't this being taught in school? Like, I never heard of anything like this before. So, and I was like, Perry, this needs to be in the schools. Like, it needs to be introduced, and just this, and I was thinking, how is Perry, who is an electrical engineer, able to understand and explain DNA and genetics better than I can understand it. And I loved the stuff. I studied it. I wanted to support this to get the information out into a broader arena. And obviously the $10 million prize might be incentive for people, a little bit more incentive than just like, I don't know, like I don't know how much you win in a Nobel Prize, but
it's less than that. Less than that. So this is a wonderful challenge prize. Thank you, Kevin.
Thank you.